Orientation. We're at stage S3, deploy and supply. The part of your system you didn't write but pulled in. Pre-trained models, datasets, packages, and MCP servers. Every one of them executes inside your trust boundary. We'll trace how a poisoned link gets in, then drop verification and sandbox gates at the door. The AI supply chain and securing MCP. Stage 3, deploy and supply. LM3, everything you pull in runs as you. 6 stages, data, train, model, supply, infer, agent. Today we light up stage 3, supply, under governance, zero trust, and monitoring. Your AI app is mostly stuff you pulled in. A pre-trained model, datasets, packages, and MCP servers. 4 supply links, every one runs inside your process. Every one of these crosses into your trust boundary the moment you load it. That's what makes supply chain different from model attacks. You invited it in. Poison any link before it reaches you. Tampered weights, poisoned data, malicious package, rogue MCP server. You never get breached, you just install it. A documented pattern, a trusted org's namespace name lapses. Someone else re-registers the same name. Your pull by name now resolves to their model. Model namespace reuse. An MCP server is a tool plugged straight into your agent. Malicious or just overscoped with hard-coded secrets. Either way, it's a supply chain door. Same plug standard, new attack surface. Once it's in, it runs as you. The model loads, the package imports, the MCP tool acts. Same identity, same secrets, same blast radius as the code you wrote. Gate 1, pin by hash and verify a signature before load. Unsigned or mismatched artifacts fail closed. Zero trust posture, allow known good, block everything else. Gate 2, keep an IBOM so you actually know what's loaded. Every model, dataset, package, and MCP server with versions and hashes. Then scan model files for unsafe deserialization, the classic load time code execution risk. Gate 3 for MCP, vet the source, scope at least privilege. The overscoped grants shrink to just what's needed. Sandbox it, and keep secrets in envars, never hard-coded in source. Same compromise, gated at the door. Unverified artifacts never cross the boundary. The model is pinned, the package signed, the MCP sandboxed. Your AI app stays clean. You secured the supply chain. Next, hand the model tools and autonomy, and you're at the agent stage, excessive agency. Break it on the board, not in prod. So, models, datasets, packages, and MCP servers are all supply links, and any one of them can carry the compromise into your trust boundary. The namespace reuse case shows how cheap that can be. Break it by pinning and verifying signatures, keeping an ABOM, scanning models, and vetting and sandboxing MCP servers with least privileged scopes and secrets in env, never source. Next, hand that model tools and autonomy, and you're at the agent stage. Break it on the board, not in prod.